Hello everyone, in this video we're going to talk about how to solve a system of nonlinear equations using the method of substitution. So specifically in this video we're going to talk about how to solve a system that has a linear equation and a quadratic equation. So let's get into it. The first example says y equals x squared plus x minus 1 and y equals negative 2x plus 3. So if we think back to substitution, since these two equations are equal to y, we can set them equal to each other. So I'm going to say x squared plus x minus 1 equals negative 2x plus 3. Now with quadratic, since we have a quadratic in here, our goal would be to set this equal to 0 so that then we can use the zero product property to see if we can factor it and find our solutions. So I'm going to add 2x to both sides and I'm going to subtract 3 from both sides so that over here on the right side we just have 0. So now we have x squared plus 3x minus 4. So now we have a trinomial and we want to see if we can factor it. So we want to think, what are two numbers that add to 3 and multiply to negative 4? Well, we know to multiply to negative 4, we probably need negative 4 and 1 or 1 and negative 4, okay? Well, if we're thinking about adding to a positive 3, then we would like our larger number to be positive, right? So this is going to give us x plus 4 and x minus 1. Okay, so our two numbers there, 4 and negative 1, multiply them, they equal negative 4. 4 plus negative 1, or 4 minus 1, would give us 3. So we know we're good there. So now, since we factored it and it's equal to 0, we can set each of these expressions equal to 0. So we can say x plus 4 equals 0. So we get x is equal to negative 4. And we could say x minus 1 is equal to 0, and we get x is equal to 1. So now, that's the x coordinate of our two solutions. So we have negative 4 comma something and 1 comma something. So what we're going to do is take those two x coordinates and plug them back in. You can do either one of these original two equations, but the linear equation is going to be easier to solve for y. So let's take each of these numbers and plug them in. So I'm going to say y is equal to negative 2, and I'm going to plug in negative 4 plus 3, and we get y is equal to 8 plus 3, and we get y is equal to 11. So our first solution, or one of our solutions, is negative 4 comma 11. And then we're going to do the second one. We're going to say y is equal to negative 2 times 1 plus 3. So y equals negative 2 plus 3, and y equals 1. And we have our two solutions. So this would be an example of having, if we were to graph, there would be two intersections. And our two solutions are negative 4, 11, and 1, 1. Okay, now let's look at number 2. Same thing, we have two expressions that are equal to y, so we can set them equal to each other. So let's say x squared plus 4x equals negative 4. Once again, we want this to be equal to 0, so let's add 4 to both sides. So we get x squared plus 4x plus 4 is equal to 0. And now, hopefully, this trinomial we can recognize as a perfect square trinomial, which means it's going to factor as the square of a binomial. So we get x plus 2 quantity squared is equal to 0. And now we can solve that by taking the square root of both sides. So we get x plus 2 is equal to 0. Now we subtract 2, and we get x is equal to negative 2. And so now that is our x coordinate for one of our solutions, and let's plug that back in. Now in this case, we can't plug it into our linear equation because we don't have an x in there. It's just y equals negative 4. So we do have to plug it into our quadratic. So now we're going to get y is equal to negative 2 squared plus 4 times negative 2. So y equals 4 minus 8, and we get y equals negative 4. So our solution here would be negative 2 comma negative 4. And that's how we solve a system of nonlinear equations using substitution.